Assalamualaikum warahmatullahi wabarakatuh. We are from Group 9 and will be presented of Lajak Kuruih Tablet I. We would like to thank you for Dr. Nurhaiza already teach us for this subject at this semester. And this is our group member, Dennis Lee Jia Yang, Faisal Abdurrahman, me Muhammad Al-Farizi, and the last one, Prima Aditya Pratama. And I will be present of the introduction and the summation of data collected. And introduction, Lajak Kuruih are famous among Malaysian, which is produce health supplement diet tablet. And in this report, we discuss the statistical parameter and various kinds of hypothesis testing that are carried out on 200 sample observation taken at random from 3 production shifts run daily, namely morning, evening, and night during December 2020 for Tab I Lajak Kuruih tablet. Summarization of data collected. The first column chart is for weight of tablet. And we can see there are 60 tablets having weight between 345 and 355 milligram, which is the highest frequency, while only one tablet having weight greater than 385 milligram. And which is the lowest frequency out of 200 samples. Generally, the weight of tablet is approximately following a normal distribution, as the shape of the column chart is similar to a normal distribution curve. A goodness of fit test will be carried out to test this statement. The weight of tablet has a mean of 350 milligram and a standard deviation of 14.37 milligram. And the next is the column chart for relative density of tablet. And there are 42 tablets having relative density tablet between 88 and 89%. Which is the highest frequency, while there is no tablet having relative density between 93 and 94%, which is the lowest frequency out of 200 samples. The relative density of tablet has a mean of 88.02% and a standard deviation of 2.07%. And the last is the column chart for tensile strength of tablet. There are 44 tablets having tensile strength of 7.1 megapascal, which is the highest frequency, while there is no tablet having tensile strength of 6.6 megapascal, which is the lowest frequency out of 200 samples. The tensile strength of tablet has a mean of 7.1 megapascal and standard deviation of 0.19 megapascal.
Hello everyone, I will continue for the part B, which is question of does the tablet follow the standard and requirement from the Food and Drug Administration FDA authority? Let's find it out. According to the standard set by Food and Drug Administration FDA, the weight of tablets produced by manufacturer should be normally distributed with 350 mg and standard deviation of 400 mg. Therefore, you need to carry out a goodness of fit test to determine whether there is a sufficient evidence that tablets produced in December 2020 by Lajak do follow this distribution. When we carry out a goodness of fit test, we need to have the hypothesis when two hypotheses, which is HO for the tablets one produced in December 2020 by Lajak do follow normal distribution with a 350 mg and standard deviation of 40 mg. And for the second one is H1, which is the tablets one produced in December 2020 by Lajak do not follow normal distribution with a 350 mg and standard deviation of 14 mg. Before that, we need to setting the decision rules for goodness of fit test, which is it is a one-tail test and the critical region always lies in the upper tail, and the decision rule is to reject H as not if the test statistic is greater than the critical value or lies in the critical region. Next is the test statistic. We carry out the data given with being categorized with between 1 to 9 from x less equal than 315 to x greater than 385 and with frequency to determine the x square. As we can see from the test statistic above, since the expected frequency for first and last observation is less than 5, therefore, two observations are merged. And we have conducted the correct of test statistic in the next step. The first observation, which have a 7 of frequency are x less than equal to 325 And the last frequency is got 8 for x greater than 375. Next one, we have the probability value and we can calculate with the frequency to determine the EI and we can conduct for the x squared test. And the result, we obtain the total of the x squared test, which is 1006x45. As we remember in the beginning, for the rejected hazards are when the x squared statistics tests are bigger than the x squared critical value. To sum up, we obtain of x squared critical value is 125,916. Therefore, the hash is not rejected and there is a sufficient evidence to support table 1 produced in December 2020 by Lajak Lakudu follow normal distribution from the FDA. Okay.
Hello, my name is Faisal. I will continue to the next topic, which is testing on whether there is any significant difference between tablet weights produced on different shifts. As the tablets are produced during 3 different shifts, including morning, evening, and night shift, therefore we are interested to find out whether there is any significant difference between tablet weights produced on different shifts. For this testing, we will use one-way analysis of variance, which is one-way ANOVA. The one-way ANOVA specifically allows us to compare several groups of observation, all of which are independent but possibly with a different mean for each group. So next, we go to the table of ANOVA. So the first step we must classify the shift and we find out the total and the value of mean. After that we can calculate the square the square mean and until we get the p value. From the table, the following conclusion which is p value is 0.743087 is bigger than alpha is equal to 0.05. The 0 is not rejected and we can conclude that there is no significant difference between table weights produced on different shifts at 5% significance level. This means that the weight of tablet I produced doesn't depend on the shift. Okay, that's all from me. Thank you. I will pass to my friend.
Next, I will talk about the relationship between tensile strength and relative density. The hardness of tablet can be represented by its relative density and tensile strength. According to study, the tensile strength of tablet depends on its relative density. Therefore, we create a regression model to determine the relationship between tensile strength and relative density of Lajak Laku tablet produced. This figure shows the summary output of the regression analysis. For more info on it, please kindly refer to the appendix attached in the report. Next is the scattered diagram drawn using the data before. The relationship between tensile strength and relative density can be shown in the linear line, which has the following equation, where y represents the tensile strength in megapascal, while x represents the relative density in percentage. Next is the linearity of regression model created. After creating the regression model, we need to carry out another ANOVA analysis to test for the validity of the model created. Testing the statistical hypothesis about the model parameter is an important part of assessing the adequacy and significance of a linear regression model. The first step in this analysis is stating the hypothesis. The null hypothesis is beta equals to 0, while the alternative hypothesis is beta does not equals to 0. If we fail to reject hash knot, there is no linear relationship between tensile strength and its relative density. However, if we reject hash knot, the relative density is important in explaining the variability in tensile strength. We reject hash knot if the value of significant f is less than the significant level. From ANOVA table, the value of significant f is equal to 2.411 times 10 to the power of negative 54. Since significant f less than the significant level, Thus, H0 is rejected and we can conclude that the data provide sufficient evidence to support the linearity between relative density of tablet and its tensile strength at 5% significant level. This means that we can use the relationship of 10 before to predict the value of tensile strength at certain relative density. Next is the prediction of tensile strength value. Recently, a batch was found to produce cluster of tablets that show low relative density value of 68%, 74.3%, 80.1%. The relative density of tablet plays an important role in determining their performance. Therefore, we are required to predict the tensile strength for such tablet using the relationship determined before. The value of the tensile strength are shown in the table as follows.